Hey, I'm Ville. This is the story of how I built a replacement for this thing here, which is an electric heating controller at my parents' home. This could be thought of as a 1980s version of a smart thermostat. It was quite sophisticated for the time, had 13 different zones with separate temperature sensors for each. Despite this quite cryptic interface, each of them could be programmed for a weekly schedule. And best of all, no internet connection was necessary for heating the building. It worked for more than 25 years until it started to malfunction and reprogram the temperatures randomly. So this quite expensive device needed to be replaced. And that seemed like an interesting thing to build. So without giving it much thought, I told my parents that I could build a modern replacement for this. As you can see, I was curious about electricity quite early on. When I was a bit older than this, I used to disassemble some old electronic devices and sometimes even put them back together. People I've told about the project have asked me if I have some background in electrical engineering. No. I don't have an engineering degree, and I think to build this kind of projects, you don't need to have an engineering degree. You need to be curious. So I was curious and popped open the old device, and this is what I found inside. On the right, there's a power supply, which powers the board on the left. On the bottom, you can see a connector with a lot of cables coming to it, and those are from all the different temperature sensors. And then this board controls another board at the top, which is the high voltage side that controls all the heating elements and also outdoor lighting and that kind of stuff. So because it seemed like this microprocessor board thing was obviously busted, I got rid of it, and but kept the high voltage side so I wouldn't have to electrocute myself while doing this. And I replaced the microprocessor with Raspberry Pi, which is a small and affordable single board computer that you can run Linux on, so you can use Nodejs or whatever you want. And then I needed to make it read these temperature sensors and control the high voltage outputs. After studying the old instruction manual of this old system that I found out that these temperature sensors were BT100 sensors, which apparently is a pretty common type of resistance-based thermometer used in the industry. And after more digging, I found a component that I could use to read it. Here's the data sheet of the component. I needed to have 12 of these. And then I also reverse engineered the old board a bit more to find out how to interface with the relays on the high voltage board. So after studying it under a magnifying glass, and figuring out which components it had, studying the data sheets of those components, I learned that in order to turn a certain relay on, all I had to do was pull the corresponding pin on the connector to 0. So armed with this new knowledge, I designed a circuit board. And I had never designed a circuit board before, so I had to learn to use this software named Eagle. And I carefully read the data sheets of the components I wanted to use, and then in the end ended up with something that I thought could work. And then I got it manufactured in China. And I can very warmly recommend this experience because there's nothing quite like receiving something you've spent a few sleepless nights designing in the mail, and then being able to hold it in your hand, and it's like, it's one of the greatest feelings ever. Also, both a cheap hot air soldering station and soldered all the surface mount components to this thing. And one thing I noted that was that all these materials were very inexpensive. Getting this manufactured in China, about 25 euros plus shipping for the minimum batch, which was, I think, 7 of these. I only needed 1, but... and the soldering station cost about the same. And the components, you can, and if you're building something non-commercial like this, like a prototype, you can usually get them free as samples from the manufacturers. So this is very little compared to all the time it takes to design these things. So after having soldered this thing together, I plugged it in. And this was quite a risky situation because for context, when I was doing this, it was a very cold winter night. The temperature outside was minus 20 degrees Celsius, going down. And when I was plugging the cables, I had to remove the old thing, which was still sporadically working. So I had to turn the heating off when I was doing it and plug in all these cables for the temperature sensors and get them right. And then I turned it on, and it worked. So if you're curious about building some electronics of your own, here are some good resources that might be useful. I found a lot of good information for very specific problems that I had from different forums like Raspberry Pi, Arduino, all about circuits forums. Also the data sheets of components, which are like a documentation for that exists for any component out there. You can download them from the component manufacturers' websites. Those are also very good and detailed information about how to use those components, what are their features, and they take a bit time to sort of get used to, but they're also very good. source of knowledge, and also available on these websites are application notes, which are then more general guide, for example, how to use multiple components together on your design. Even they might even include a sample design that you can use as a basis for your own. And another website I can warmly recommend is Adafruit, which has a lot of interesting, inspiring projects and tutorials, for example, on how to use a certain sensor, and they also include a lot of code samples on GitHub or even libraries that you can easily get started with. Next, let's look at the software side of things. I made this control loop with Python that runs on the Raspberry Pi. So it's a program that runs on a cycle of 1 minute, reads the set temperatures from an SQLite database. Then it reads the temperature for each sensor, and then sets the heating on or off for each room based on the set temperature and temperature that's read from the sensor. I also write the temperatures to the database so they can be shown to the users, or I could analyze them later. And then it sleeps for a minute and runs again. Both of my parents have iPhones, so I also wanted to make this system connect with HomeKit, which is Apple's protocol. Using HomeKit, they would be able to use the built-in Home app on iOS to set the temperatures, turn the lights, the outdoor lights on, and so on. Unfortunately, it's a proprietary protocol, and at the time when I was doing this, even the documentation was only available to members of Apple's licensing program. It is available now, but for non-commercial purposes. But fortunately, there's this open source library that someone made by reverse engineering the protocol, and it works great. So armed with this library, I created a Nodejs server running on the Raspberry Pi that talks with HomeKit, just writes all the current state and settings on an SQLite database, where it then gets read by this control loop that I talked about before. And it works. It works with all of HomeKit. And another nice thing about integrating with HomeKit is that we can use Siri to set the temperatures in the building. But HomeKit didn't support everything I wanted this thing to do. In particular, triggering a scheduled action was only possible when an iPhone was in the network at home, or alternatively, if there was an Apple TV connected. And I didn't want the heating of the building to depend on either of these things. So I built my own app with React Native. I added a GraphQL API to the Raspberry Pi server, and then used Expo to build this React Native app that allows people to edit the weekly schedules. So these are some of the things that I used for building this app. Expo provided a very nice tool chain for working on the app. React Navigation is a good navigation library. An Apollo client, possibly the best library for fetching data. And it worked with the GraphQL API that I've added to the server. So, so the schedules were created using this app. Then the server just saved them in the database, and the control loop every minute would read the current temperature and adjust the heating accordingly. I think building supporting applications for appliances like this is a very compelling use case for React Native. I can just imagine all the connected devices that will be created in the next couple of years. And with React Native, we can build remote controls for all of them. And the apps will be cross-platform out of the box. Next, I'm just going to talk about a few ideas about additional technologies that might be useful for hardware projects. For networking, you could use a Wi-Fi network like I did in my projects. But wouldn't it be nice if when the connected device is in the same network as your phone, the phone would detect it automatically, discover its IP address, and be able to connect to it. Luckily, there is a protocol made for just this purpose named ZeroConf, also known by the name of Apple's implementation of it, Bonjour. It allows a device to broadcast their name and IP address, much like a DNS service, to other devices. And then those devices can connect with them without having to type the IP address in the app. And it's, for example, used by HomeKit itself and AirPlay, for example. And there is a native module that I found that exists for using ZeroConf with React Native. Alternatively, you could connect directly with the device using Bluetooth Low Energy, or BLE. It is also available for React Native through some native modules. And this protocol is also used for iBeacons, which are small transmitters that can be used for various applications like geolocation inside buildings. And You're going to hear more about iBeacons in Vladimir's talk tomorrow, I think. At the end, I would just like to say that building this project was a lot of fun. So if, like me, you're curious about electronics, I encourage you to give it a try. Pick some project that you are interested in. It can be quite ambitious, and then just make it work. Thanks.